Today's lesson is on ratios. First, we're going to look at our key idea for ratios. A ratio is a comparison of two quantities using division. A ratio of 2 red crayons to 5 blue crayons can be written in 3 ways. The first way you can write it is as a fraction, 2 over 5. The second way you can write it using the word 2 in between the two numbers, so 2 to 5. And the third way, you can use a colon in between the two numbers, and you read this as well, 2 to 5. For our first example, we're writing a ratio. Write the ratio of pennies to quarters in 3 ways. If you look at the picture, we can count up the number of pennies. We have 1, 2, 3, 4, 5, and then we can count up the number of quarters. 1, 2, 3, 4, 5, 6, 7, 8. So we have 5 pennies and 8 quarters. The 3 ways to write this is as a fraction, 5 to 8. 5 would be the numerator, 8 would be the denominator. We can write it with the word 2 in between, so 5 to 8, or we can write it using a colon, 5 to 8. Since pennies was the first thing that it asked for, that's why that number, 5, is first on all of these. It's the top number for the fraction, and it's first for the other 2 ways. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. In example 1, write the ratio of quarters to the total number of coins in 3 ways. Again, we have our picture, and the number of quarters is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 quarters, and we have 1, 2, 3, 4, 5 pennies. If there's 8 quarters and 5 pennies, there's a total number of 13 coins. So if we want to write the ratio of quarters to the number of coins, there are 8 quarters, and there are 13 coins. It would be 8 to 13. We can write that as a fraction. We can also write 8 to 13 with the word 2 in between. Or we can write 8 to 13 using a colon. So 8 to 13. For our second example, we're writing and simplifying ratios. For A, write the ratio of boys to girls at Oak Grove. If you look at our table, there are 600 boys and there are 540 girls. So the ratio of boys to girls, we put boys on the top of the fraction and girls on the bottom because boys is listed first, so it would be on the top. Boys would be 600, girls would be 540, and then we can simplify our fraction. We can simplify by dividing by 60. 600 divided by 60 is 10, and 540 divided by 60 is 9. So the ratio of boys to girls is 10 to 9. For B, write the ratio of girls to the total number of students at Oak Grove. The table tells us that there are 540 girls. If we add our total number of students, we add boys plus girls, we get 1,140. Now we can simplify. So our ratio is 540 to 1,140. We can divide both of these by 60. And when we divide both of them by 60, 540 divided by 60 equals 9, and 1,140 divided by 60 equals 19. So the ratio of girls to the total number of students is 9 to 19. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. Write the ratio of boys to the total number of students at Oak Grove in simplest form. Once again, we have our table. There are 600 boys and 540 girls. If you add those two numbers up, you'll get 1,140. So the ratio of boys would be 600 to the total number of students would be over 1,140. Now it wants it in simplest form. We can divide the top and the bottom both by 60. And when we divide the top by 60, we're going to get 10. And when we divide the bottom by 60, we're going to get 19. So our ratio of boys to the total number of students at Oak Grove is 10 to 19. Now we're going to look at our vocabulary. Two ratios that describe the same relationship are equivalent ratios. For our third example, we're writing equivalent ratios. Write two equivalent ratios for triangles to squares. So first we need to write our ratio for triangles to squares. If you look in the picture, we have 1, 2, 3, 4 triangles, and 1, 2, 3, 4, 5, 6 squares. So our ratio for triangles to squares is 4 to 6. To write an equivalent ratio, we can either multiply or divide. We're going to multiply or divide both the numerator and the denominator by the same number. So we can divide both the numerator and denominator by 2. When we divide 4 by 2, we get 2, and when we divide 6 by 2, we get 3. So our ratio is 2 to 3. So two equivalent ratios are 4 to 6 and 2 to 3. If you look at the reading box, it says the ratio 2 to 3 means that for every 2 triangles, there are 3 squares. Now we have an additional example. You can either pause the video and try it on your own, or you may follow along. Write two equivalent ratios for the given ratio. For number 3, we have 4 to 8. For 4 to 8, we can either multiply or divide to get equivalent ratios. If we multiply both of these numbers by 2, 4 times 2 would be 8, and 8 times 2 would be 16. So 8 to 16 would be an equivalent ratio. We could also divide to get an equivalent ratio. If we divide both of these numbers by 2, we would get 4 divided by 2 is 2, and 8 divided by 2 is 4. So 2 to 4 would also be an equivalent ratio. Other answers you might have had for this problem are 1 to 2, because you could divide them both by 4, or 12 to 24, because you could multiply them both by 3. There are also other answers that would be correct for this problem. For number 4, we have 3 to 7. We can multiply both 3 and 7 by 2. So 3 times 2 is 6, and 7 times 2 is 14. So 6 to 14 is an equivalent ratio. We could also multiply both 3 and 7 by 3. 3 times 3 is 9, and 7 times 3 is 21. So 6 to 14 and 9 to 21 are equivalent ratios. For this one, we could not divide to get an equivalent ratio because 3 to 7 is in simplest form. Other answers that you might have had would be 12 to 28 or 15 to 35. Additionally, there are other answers that you could have had. For number 5, we have 5 to 20. For this one, we could divide both 5 and 20 by 5. So 5 divided by 5 is 1, and 20 divided by 5 is 4. So 1 to 4 would be an equivalent ratio. You could multiply 5 and 20 by 2. 5 times 2 is 10, and 20 times 2 is 40. So 10 to 40 would also be an equivalent ratio. You might have had 15 to 60 as well if you multiplied by 3. Again, there are other answers that would be accepted for this problem. For our fourth example, we're comparing ratios. You answered 24 out of 30 questions correctly on a quiz. Your friend answers 35 out of 40 questions correctly on a different quiz. Who has the better score? In order to find this out, we're going to write our ratios first. If we answer 24 out of 30, that would be 24 to 30. We can then simplify this to 4 to 5. If our friend answers 35 out of 40, we write this as a ratio 35 to 40, and then we simplify, that is 7 to 8. We can use percents to compare the scores. So you had 4 to 5. When you divide that, that would give you 0.8 or 8 tenths. 8 tenths as a percent would be 80%. Your friend has 7 to 8. When you divide that, you would get 0.875 or 875 thousandths. As a percent, that would be 87.5%. Remember, to make your decimals into percents, you move the decimal 2 places to the right. So 1, 2 puts it behind the 7 before the 5. Now when we compare our percents, you can see that your friend has the better score. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. You catch 18 out of 25 passes. Your teammate catches 23 out of 30 passes. Who has the greater catch ratio? Explain. Well, if you have 18 out of 25, we can write that as a ratio 18 out of 25. And your friend has 23 out of 30. We can also write that as a ratio 23 out of 30. To find our decimal, we need to divide. So we can do 18 divided by 25. 25 will not go into 18, so we put a decimal in our 0. And now 25 goes into 180 7 times. And 7 times 25 is 175. When we subtract, we're going to get 5. We would add our 0 and bring it down. And 25 goes into 50 2 times. 2 times 25 is 50. We're going to subtract, we get 0, so we're done. Now we can convert 7200, so 0.72 into percent by moving our decimal 2 places. So 1, 2 would make it 72%. For our teammate, who has 23 out of 30 passes, we would then again divide 23 divided by 30. We had our decimal and our 0 because 30 does not go into 23. And now 30 goes into 230 7 times. And 7 times 30 is 210. When we subtract, we're going to get 20. Now we add our 0 and bring it down. And 30 goes into 200 6 times. 6 times 30 is 180. And now we can subtract again. And we're going to get 20. If we add our 0 and bring it down, you'll notice that we have 200 again. 30 is going to go into 200 6 times. And you'll notice that we're going to keep getting 20 when we subtract. We'll add a 0, bring it down, and get 200 again. So this is going to be a repeating decimal. The 6 is what's repeating. When we move our decimal over 2 places, 1, 2, to make it a percent, that'd be 76.6%, and the 6 is repeating. So 76.6 repeating, and that would be then your percent. So now if you compare these two numbers, 72% and 76.6%, we can see that our teammate has the greater catch ratio. Don't forget to fill out your notes, and remember to watch the video again if needed.